Now, in our past videos, we told you that if you want to find the nth derivative of a function, you differentiate the function for the first, second, third, fourth, or fifth time. So you find the first to the fifth derivative and observe a pattern in each of the derivative and write the result in terms of n, as we told you. So we are going to use that very same rule to find the nth derivative of this. So we have y is equals to 1 plus x raised to the power of -1. The first derivative of y is y prime. In this derivative, we are going to multiply the power by the coefficient and then rewrite the function and subtract 1 from this power, so we have -2. So the first derivative is -1 multiplied by 1 plus x to the power of -2. That's the first derivative. Now, according to the chain rule, we should multiply by the derivative of the function in here. But then the derivative of 1 plus x is just 1. So we'll move on to find the second derivative, y prime prime. Multiply this by this, so we'll have -1 times -2. And then we have 1 plus x raised to the power of -3. Always multiply the power by the coefficient and subtract 1 from the power. So the third derivative we have y prime 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 is equals to, multiply this by this, we have -1 times -2 times -3 multiplied by 1 plus x raised to the power of -4. That is the third derivative. Now we also want to find the fourth derivative of that function. So to find the fourth derivative, we move on and write. So I'll write y rv4. So this is rv4. This will be equals to -1 times -2 times -3. Multiply the power by the coefficient, that's -4. Rewrite the function 1 plus x and subtract 1 from this power, that's -5. Great. So I found the fourth derivative for the first fourth derivative, and I think it's sufficient for us to determine the pattern right here. So we'll continue this in this order. We have y to the n. So y to the n is the nth derivative. Let's observe. The first derivative is negative. The second derivative is positive. The third derivative is negative. The fourth derivative is positive. So I'm looking at sign change. So if the first derivative is negative, that means I want to look at the sign change. I'll have -1 raised to the power of n, where n is, and then counting number, so we'll start from 1. First derivative, second derivative. So if n is 1, the first derivative here will be -1 to the power of 1. And that will give us negative. Now, let's observe the coefficient. Here, for the first derivative, we'll have 1. The second derivative will have 1 times 2. The third derivative will have 1 times 2 times 3. The fourth derivative will have 1 times 2 times 3 times 4. So because of the arrangement of the numbers like this, we say that this 1 is 1 factorial, 1 times 2 is 2 factorial, 1 times 2 times 3 is 3 factorial, and this is 4 factorial. So for this entire coefficient, we have n factorial. And then we'll move on to write, parenthesis will be 1 plus x raised to this power. Here you have -1, -2, -3, -4, -5, and so on. So from each power, from -1, we add -1 to give us -2, add another -1 to give us -3. So in this case, it will be like n plus 1. So we'll put a negative outside, and we'll have n plus 1. To show that whatever value of n we put here, this negative will be multiplied by the entire result to make the entire thing negative. So what happens here is, for the first derivative, if n is 1, we have 1 plus 1, which will give us 2. If n is 2, we have 2 plus 1, which will give us 3. If n is 3, and so on. So we take this and put it in the denominator. We put it in the denominator, then we have y to the n is equals to -1 to the power of n times n factorial. This goes in the denominator. We have 1 over 1 plus x raised to the power of n plus 1. So this negative becomes positive because it goes in the denominator. So I will just simplify. Y to the n will be -1 to the n times n factorial, all divided by 1 plus x raised to the power of n plus 1. Ladies and gentlemen, this is the nth derivative of the function 1 plus x to the power of -1. Using this, I can find any derivative. I can find the 50th derivative,
The fifth derivative.
and so on. Thank you very much for watching, and we hope you subscribe to our YouTube channel and click the notification bell so that you won't miss future update. Peace.